Welcome. Welcome to video number 8 of my series about the Korg Volca modular in cooperation with other affordable but very capable synthesizers, synth modules, and semi-modular synths to complete my Eurorack system, my hybrid Eurorack system. Today I'm talking about some hacks, 2 hacks concerning the Werkstatt, Moog Werkstatt-01, 2 hacks to remove some deficiencies. The Werkstatt provides me with an original Moog filter here, and I want to use this Moog filter not only to filter the VCO of the Werkstatt itself, but also to filter, to modulate different other sound sources here from the system. And luckily there is VCF audio input here, so I can feed in external audio signals directly into the filter. But doing so, I have to discover the first deficiency, and this is that I always hear the VCO, the Werkstatt's own VCO, together with the signal, audio signal coming in here at the VCF audio in. The VCO is hardwired, internally hardwired to the VCF. What a pity. Well, let me demonstrate this. I know that my studio is a mess, look here, but after a really serious COVID disease, I had to survive and completely break down of my IT system here in the studio. I haven't yet managed to set up everything properly. But back to our matter of the video today. So at first I have a short sequence running on the Korg Volca modular. Let's listen to it. I take my headphones on so that I can listen it as well. This here. And from the Werkstatt comes only a constant single tone. This one. All right. So now I take the source output from the Korg Volca modular and patch it into the audio in, VCF audio in. And now I open only on the mixer the channel of the Werkstatt. So not this one, but this one. And we hear both. I can filter both. Distortion all over the place. Here, so I turn it down a bit. So you hear we have both sound sources at the output of the Moog Werkstatt. This is something which I'm going to change now. The solution is ridiculously simple. Hardwired? Well, okay, cut the wire then. Well, there are a few aspects to consider though, but let me demonstrate the second deficiency before I start and solve all problems together. When we compare the strength of the audio signal that comes out of the VCO out jack of the Werkstatt with the signal strength which other modulars and semi-modular synths let their VCOs send into the world, we discover that the Werkstatt's VCO emits 0 to plus 5 volt, that's the range, whereas the others, for example my neutron, outputs minus 5 up to plus 5 volts. And with the VCF out in the Werkstatt, it's the same. Let me prove that. So I take the VCO out and put it into my oscilloscope. And you see the whole wave is on the upper part, on the positive, and we have a peak-to-peak voltage of 4.75 volt, so not really 5 volt. 0 to 5 volt. Let me increase it. You see it better. Okay, so let's go back. Now I take the output. I take the output of the neutron. I could have used, if I had other original Eurorack modules, I could use them. And here we see we have peak-to-peak voltage 10.8 volt, and it goes from minus to plus. The little figures here show it as well, but in the graph it's nicely to be seen. Okay, not that much of a problem, you might say, but think of using the VCOs or VCF's output of the Werkstatt as modulation source for other modules, together with oscillators which put out double the range of signal strengths. You will run into quite a mess at once. I will have to expand the Werkstatt's 0 to plus 5 volt output to the more common minus 5 volt to plus 5 volt output to make it a worthwhile and emancipated partner of my other and future modules in my rack. Well, it's time to solve the problems, but before I take a screwdriver and a soldering station, I'd like to list the 4 most common alternatives to solve the VCO output input problem. VCO audio input problem, of course. So the first alternative you find very often is the simplest one. Simply cut the wire, meaning cut or remove jumper 57. I'll show it later on the PCB. The second is remove jumper 57 and insert a simple on-off switch instead. The third alternative is do it as the Moog CV expander manual suggests. Cut jumper 57 and solder a wire jumper to the jumper position J1, which is at the CV expander PCB. Without any external audio plugged in, the VCF will still process the Werkstatt's VCO, but plugging in an external signal will break this connection. And the fourth alternative you find quite often on the web is remove jumper 57 and insert a simple audio mixer circuit instead. I have decided to follow alternative 2, inserting a switch. Why do I prefer this? Well, as I said in more than one of the last videos in this series, I like to see the Werkstatt not as a unit, but as a bunch of individual and independent modules at a very reasonable price. Alternative 1, simply cutting jumper 57, would make the VCO and the VCF independent from each other, sure. But I may want to feed the Werkstatt's VCO in the Werkstatt's VCF sometimes anyway, and so to do so I would have to patch the connection, occupying and so losing 2 patch points on the CV expander. I would have to patch the VCOs out into the VCF in with the CV expander. With alternative 2, I simply turn the switch to reconnect the VCO and the VCF again. Alternative 3, the one suggested in the CV expander manual, is very similar to my switch solution, but less obvious. And alternative 4, the audio mixer thing, is not, well, it's not modular enough in my eyes. It's kind of leaving the modular systematic. If I want to boost or attenuate one signal to the advantage or disadvantage of another one, well, then I use a mixer module. The patch cables will clearly show the goings on then. All right, let me move over to my little electronic laboratory and get my hands dirty now. Well, let's go for it. Let me open the case to find the location of the jumper 57 and to find a good place where to install this switch, simple on-off switch. Okay, so remove the CV expander. Yes. Yeah. And remove the two other screws. So of course I've found and I've shown you the position of the jumper 57 in the circuit, in the schematics. So let's go for it. Here is the VCO. And so I have to remove my glasses and take this. No, I don't need it. I don't need the magnifying glass. So jumper 57 is VCO, the VCO circuit, the VCF is here. So somewhere jumper 59, jumper 60, 61, here. I don't touch the circuit with it. Here it's, yeah, jumper 57. Here it is. Perhaps you can see it through my magnifying glass. Here. Yeah. All right. Yeah, so I have to remove this and to solder this switch in. So next question is where to place it. Let me have a look. Yeah, I think here. Question is on the front panel, perhaps on the front. Why not on the front panel? Let me have a look. Here. Exactly between here. This would be a nice place to go. But no, it will touch. It will probably touch the PCB. Yeah. Yes. No, it's impossible on the front. Ah, it's a pity. It's a pity. So I have to place it here, and then I have to remove. Yes, I have to remove the PCB. Drill a hole. What about this side here? With longer wires. No, it will be under. It would be under the expander. Well, somewhere here above, I have to remove the PCB now and drill the hole in it. Yeah. Okay. Let's do so. My glasses first. So now I'll insert the PCB again, and then it's all about cutting and soldering. And the main audio output. All right. So a short control. Here. With the beeper. Yeah. So right. So now I have to cut this and solder these two wires in. Wow, it's quite hard. So, testing the result. At first, I opened the channel, the mixer channel, where I have my Werkstatt plugged in. Nice pulse width modulation sound. And now I feed in the sequence from the Korg Volca Modular into the VCF or external audio in. And still the situation as we know from the beginning, the VCO goes into the VCF and adds to the Korg Volca modular sound. Now I switch to clear and clean Volca modular sound, which I now can tweak with a VCF of the Moog. All right, I remove it again, and there is no sound. VCF and VCO and VCF are disconnected. Now they are connected again. Great. What's left to do? Well, I think I should make some labels so that even after some time of not using it, let me dim it. After some time of not using it, I at once will know where is the connected VCO VCF version and the disconnected one. All right. Expanding the output range and offsetting 0 volt to -5 volt now. I've decided to make an independent module for this task rather than placing the needed circuit inside the Werkstatt, because I have certain little synths and modules in mind whose outputs need a similar treatment. So this is for further future videos, new friends of the Volca modular. But before doing so, I have to correct myself. Sorry for that. Some minutes ago, I said that the VCF's audio output behaves like the VCO's audio output. What's the matter? Well, that's not completely true. Okay, the range is identical, around 5 volt, but the VCF outputs a bipolar signal already from about -2.5 to +2.5 volt. I will have to make two different circuits, therefore, one for the VCO with an offset and one for the VCF. I found a nice and simple solution published by Nathan Ramsden on Synth Nerd on the internet. You'll find the link to the article, to the complete article, down in the descriptions. You see that the only difference between the circuits is the 5 volt offset for the VCO's output, left schematic, whereas the VCF's output doesn't need such an offset because of its already existing bipolarity. Those of you who need further explanations of the schematics will find them at Nathan's article. I'm going to take the plus and minus 12 volt as well as the plus 5 volt from the power supply of the whole rack. The TL072 operational amplifier can be supplied by up to plus minus 18 volt, so no problem using 12 volt instead of the 9 volt which are mentioned in the schematics. I'd like to test this circuit before I before I add the jacks and make the front panel. So let me go for it. This is the VCF out. Okay, so here is the input. Just a moment. Give me a second. Yes, of course. So here is the input of the circuit concerning, no, here it is, sorry. It's a little bit dangerous without labels, but it's okay. Here the outer one is the input for the VCF. And then I take here this crocodile. And yeah, great. So it's still bipolar, as the VCF is by default, and we have peak to peak 875. That's okay. That's okay. I'm fine with that. Doesn't have to be exactly 10. It will be different as well. So let me have a look whether the resonance makes a difference. Yes, of course it does. And the cutoff as well. Yeah, changing the cutoff. Of course, changing also the amplitude. All right, so now for the VCO output, it's even more interesting whether the voltage offset works, so that it's getting from monopolar to bipolar. Okay, the white one is the input. Here is the yellow one. It's the input of the VCO circuit, the inner one. And here is the red one, the output. And again, wonderful, it works great. 9.5, 9.5 volt peak to peak, and bipolar, so the offset of 5 volt works as well. Okay, so now I can finish the module and make the front panel, inserting the input jacks. Wonderful, great. A very last test from the VCO out into the module, and from the module into the oscillograph, and we see nearly 10 volt peak to peak and bipolar. Great, things work. The module, I think it's not that bad looking, I mean. Well, thank you for watching. You may consider visiting my website. Don't forget to visit my website. And if you want to support me, just visit my shop on the website and buy something, or simply donate a little bit. Or even, you might even want to get a member of our community. On the website, you will find a menu item explaining all the great and nice advantages of being a member of our great community. Okay, once again, thanks for watching. Thanks for eventually visiting my website, and enjoy your day. Thank you, Ralph.